Good morning. Today is Wednesday, January 6th, 2021. This is the Chapter 2, Topic 2 on probability. It is called Comparing Probability and Odds. The objectives of this chapter are as follows. Learn the difference between probability and odds. Determine the odds in favor of an event occurring. Determine the odds against of an event occurring. Determine the probability of an event if you're given odds in favor of an event occurring. Determine the probability of an event if you're given odds against an event occurring. So the previous topic 1 on what is probability, you learned that you can express probability in multiple ways. But another way of expressing the likelihood of an event occurring is called odds. In this lesson, you will study odds and the relationship between probability and odds. Probabilities and odds both provide the same information about chance, but in quite different ways. Probabilities are most frequently used by mathematicians and scientists, and odds are most often used to express the chances of winning or losing in games of chance, such as betting on a horse race, etc. Also, the media usually uses probabilities instead of odds because probabilities, when written in percent form, are easier for readers to understand. So, odds versus probability on your page 2 of your notes. It's in your notes that I've just kind of summarized on the board, so if you can't see this, know that I've summarized what's in your notes that you have on paper. Odds versus probability is the likelihood of an event occurring, which can also be expressed as the odds in favor of it occurring. The probability of an event occurring and the odds in favor of it occurring are not the same. Probability of an event occurring is the number of ways of the event can occur over the total number of outcomes. Odds in favor is equal to the number of ways the event can occur over the number of ways the event cannot occur. And the formulas that you see that I've written on the board as well, the numerators are the same. However, the denominators are different. That's the bottom stuff. The numerators are at the top, denominators at the bottom. Therefore, the values you obtain for the probability of an event occurring and the odds in favor of an event occurring are different. There is also a formula for odds against an event occurring, and I'll be posting that soon. Odds against is equal to the number of ways that the event cannot occur over the number of ways the event can occur. Odds in favor is just the reverse of that, the number of ways the event can occur over the number of ways the event cannot occur. So you see that odds against and odds in favor, we just kind of flip things around. Now before I move on to talking about example number 1 on the following page, let's get back to the last little bit that I want to read here. Another important distinction between probability and odds is that odds are not written as decimals or percents, just as fractions or ratios. So here's example 1 of odds versus probability. Imagine you're randomly choosing the letter from the alphabet. All right, so this is a probability thing first for number 1A. Determine the probability of choosing a vowel, including Y as a vowel. So on the board, what I did is I said, okay, we have A, E, I, O, and U. We know those to be vowels. That gives us 5. But we include Y just for the purposes of this activity. That gives us a total of 6 vowels. Then we know in the alphabet there's 26 letters. So the probability for that one would be like this. We have 6 that are vowels that we want, but we have a total of 26 possible outcomes. So it's going to be 6 over 26. Now B says determine the odds in favor of choosing a vowel. So this is B now. So determine the odds in favor of choosing a vowel. Well, we use the words odds in favor formula. The number of ways the event can occur over the number of ways it cannot occur. The number of ways it can occur is going to be 6, because we can get A, E, I, O, U, and possibly Y. But here's the trick. It's not going to be out of 26 because we already have taken 6 out of that 26. We will have 20 other letters that are not going to give us that one we want. So it's going to actually be out of 26. The number of ways an event can occur will not be out of 26. It'll be out of 20 because we've taken the 6 vowels that are what we're trying to get in odds in favor. Now, the trick to this to doing odds against for C, you could use the formula and put it together that way, but here's the trick. odds against is the number of letters working against us to get the 6 that we want. It's going to be 20 letters working against us to give us the 6 we want. So we just kind of reverse that 6 out of 20 to be the odds against will be 20 out of 6. You flip them. Example 2. Imagine rolling a 6-sided number cube, which is a dice, and determine the following. The probability of rolling a number less than 3. So there are 6 numbers on the dice. 1, 2, 3, 4, 5, and 6. A number less than 3. Don't include 3, but a number less than 3, well, that's going to give us 1 and 2. So we have basically, for example 2a, we have 2 out of 6. The probability of rolling a number less than 3, well, that's going to be 2 out of 6. Because there's 6 numbers on the dice, we have 2 numbers that might work to our favor, getting us what we want. So then we go and say, okay, let's move on to B, the odds of rolling a number less than 3. We have 2 numbers that are going to give us what we want in favor of getting the number we want. But it's not going to be out of 6. It's going to be out of 4 because there's going to be other numbers we're going to deal with there. The other 4 numbers are going to work against us. Now, in the notes, in my notes, and I'm not sure if it's in the actual other notes, I don't think it is, you can reduce these 2. That odds in favor can be reduced to, instead of 2 out of 4, we think of what number can go into each number. Well, 2 can go into 2 one time, and 2 can go into 4 twice. So we can reduce it to 1 out of 2. You can reduce your ratios. You can reduce your odds in favor, your probabilities. And that's also something to think about if you want to reduce it. But I'm going to keep it as it is to make it a little bit easier for you to see. If this is our odds in favor of getting a number less than 3, odds against of getting a number less than 3, guess what? It's just the reverse. And that will conclude example 2. Now there is example 3, 4, and 5. So I'm going to pause the video and erase the board. After reviewing question example number 4, I realized that number 5 is pretty much the same idea. And number 4 is given to you step by step. So what we're going to do is we're going to do number 5 instead of me repeating the steps to number 4 that are already written out for you. So here's example number 5. There are 10 numbers in a hat, 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all in a hat. A ball is drawn at random that has these numbers on them. So imagine, like, instead of numbers on a ball, they're numbered 1 to 10. So the first part says, what's the probability of picking an even number? Well, we go, okay, we go 2, 4, 6, 8, 10. That's 5 numbers. And then we look at it and go, hey, you know what? We count the even numbers. That's going to be 5 out of the 10 total numbers that are there. Now you could reduce that. And you could put it in a percent form, or you could put it in a decimal. I mean, it would be 50% if you put it in a percent form. Probability of 50% chance of getting an even number. Or you could put it as a fraction. You could reduce that 5 out of 10 to 1 over 2. Well, let's get to B. B says, what are the odds for picking a 7? Well, 7 is one number out of whatever's left that's going to work against us, which will be 9 other numbers, 1 out of 9. The odds against drawing a number less than 3, well, there's 2. But if we go 2 out of 8, we're doing odds in favor of getting that number. Odds against would be reverse. So we got 8 numbers that are going to stop us from getting what we want. So that's the odds against getting the 2 that we want. Odds against, 8 out of 2. Odds in favor of getting a number less than 3 would be 2 out of 8. But they're not asking that, so be careful what you read. And D. State the odds against drawing a number less than 3. That's C. State the odds against drawing a number more than 4. Odds against drawing a number more than 4. Well, that's 5, 6, 7, 8, 9. Well, that's a few. Here's what we're going to do. What I did right away is I looked at that and went, you know what, even though it's not asking for it, I'm going to show the odds for. Because we're going to have 6 numbers that can work in our favor of getting a number more than 4. This is going to be what I call odds in favor. I'll call odds in favor. And then I went, you know what, it's easier for me to do it this. If I know the odds in favor and it's asking for odds against, then I just reverse it. I've got 4 that are going to be against me to get the ones that I want, which is the 6 that are above the number 4. That would be the odds against. Sometimes I like to do it that way because I see it faster if I see the odds in favor. And I can also just suggest if you see it right away, you know, oh, okay, I know that right away. That's 4 out of 6 that are going to work against me to get the numbers higher than 4. Now the odds for drawing a 4, well, there's 10 numbers and the one that we want. So basically odds 4 would pretty much be odds in favor. For us to get a 4, that's that one number we want, there's going to be other numbers that are going to work against us for odds in favor of it. Just hypothetically speaking, if this is odds in favor of us getting a 4, odds against it would be 9 out of 1. That's in favor, and that's against. Odds against.